In this video, we will evaluate several more derivatives with the chain rule. So as a reminder, the chain rule is for differentiating a composition of functions. And what it tells us is that the derivative of f of g of x is f prime evaluated at g of x times g prime of x. And from a more intuitive perspective, I think of this in words as the derivative of the outside evaluated at the inside times the derivative of the inside. So there's a pattern that goes along with this. So for our given example, we can look at the function that we're given to differentiate and notice an inside function, this x squared plus x plus 1. But it makes sense to maybe first rewrite this algebraically to make it as simple as possible. Recall that the cube root is raising to the 1/3 power, and the fact that it's in the denominator means that we can rewrite this as x squared plus x plus 1 raised to the minus 1/3 power. And once again, maybe for the last time with these examples, I'm going to write this out as a composition. This is f composed with g of x, where we think of this inside function x squared plus x plus 1. In the outside function, well, you think of looking at the composition and you replace that x squared plus x plus 1 with an x. So it would be x to the minus 1/3. And these are two functions that we can easily differentiate. So g prime of x, applying the power rule to each term, is 2x plus 1 plus 0, because the derivative of a constant is 0. We apply the power rule to x to the minus 1/3, so the power which is there comes down front, minus 1/3, and the new power we have for x is 1 less than minus 1/3. Minus 1/3 minus 1 is minus 4/3. So now applying the chain rule, dy dx is going to be f prime of g of x. So intuitively what we need to do is take this formula we have for f prime, and everywhere we see an x, we're plugging in that function g of x. So we take the derivative of the outside, minus 1/3, I'm just leaving a space where that x is, something raised to the minus 4/3. Then we plug in the inside function, and we multiply by the derivative of the inside function. And once again, to connect directly back to this formula, we have f prime of g of x, the derivative of the outside evaluated at the inside, multiplied by the derivative of the inside. Let's look at one more example of differentiating with the chain rule. So in this problem, we can maybe see our inside function, g of x, would be playing the role of x plus 1 over x minus 1, and then the outside function is just the cubing function, so x cubed. So dy dx, the chain rule tells us it's going to be the derivative of the outside function. So for the outside function, we need to differentiate the cubing. So we bring the power down. The new power is 1 less than the old, so it's a square. We evaluate at the inside function, and we multiply this by the derivative of the inside function. And after a while using the chain rule, I think this will become a very natural process. There's definitely some pattern recognition that goes with it, but it's something that we do have to practice to get to. So what we have in the beginning is just going to kind of come along for the ride, and what remains is this one derivative. And to differentiate x plus 1 over x minus 1, what we are going to want to do is use the quotient rule. So the quotient rule tells us low d high minus high d low all divided by the bottom squared. Now, just to make our work a bit easier, note that the derivative of x plus 1 is 1, and the derivative of x minus 1 is also 1. Because remember, the derivative breaks up over a sum, so it becomes the derivative of x, which is 1, plus the derivative of 1, which is 0. So we have the 3 times x plus 1 times x minus 1 squared. And the derivative from the quotient rule simplifies nicely. We have an x minus 1 in the top, and we're subtracting away from this an x plus 1. And the minus sign will distribute through. So we have an x minus x, so those two terms cancel, and a minus 1 minus 1. So what we're left with is 3 times x plus 1 over x minus 1 squared multiplied by minus 2 over x minus 1 squared. And I think we can do one more basic simplification here. We can note that 3 times minus 2 is minus 6. And then we can take the two fractions that remain and distribute the square in the first and then multiply the bottoms together. So what we'll have in the top is x plus 1 squared. And what we'll have in the bottom is x minus 1 squared times x minus 1 squared. So that would be x minus 1 raised to the 4th. And a very good thing to keep in mind is that when you are differentiating, it is very, very reasonable and highly likely that you will have to apply multiple techniques or rules of differentiation. Here we had to apply the chain rule to get started, but then that remaining derivative needed to be evaluated with the quotient rule. So it is very reasonable to use multiple methods for the same problem.